Greetings and welcome, friends. Today we're going to talk about graphing polynomials. Now, you've seen me use technology to accomplish these graphs, but today we're going to talk about being able to graph them based off of analyzing a table, really. So we're going to approximate the x-intercepts or zeros, and we're going to approximate kind of the hills and valleys, so to speak. So we're going to gain those techniques today. But before we do that, I actually want to talk about how you would graph using a table a polynomial that theoretically we should know how to graph anyway. What if I have f of x equals x squared plus 2x minus 3? All right, so this is a quadratic. So looking at this from our polynomial perspective, based on the degree, how many x-intercepts could it have? Right, x-int will be 2 or 0, right?
What about 1?
How many bends would it have? Oh, actually, you're right, it could have 1. Good call, good call. Yep. How many bends could it have?
1.
As many as 1 bend, and in fact, in this case, it has to have that 1 bend, because the number of bends is 1 less than the degree. And let's see, what else could we gather? Oh, the end behavior.
Oh. Okay.
Yeah, what shape is this going to be? Well, it's a positive leading coefficient. It's an even degree. The even degree tells me that the end behavior is in the same direction. Positive tells me that it opens up. So I'm just going to, what we would have called back in the day opens up for a parabola. Today we would say f of x approaches positive infinity as x approaches negative infinity. And we would say f of x approaches positive infinity. Notice it's approaching positive both times as x approaches positive infinity. So that's how we would describe the end behavior. Basically, this is saying it's going up as x goes to the left, and it's going up as the graph goes to the right? So that's kind of what that's describing. But what we're going to do real quick is make a table of values, all right? And I'm going to make a table of values, and there's a couple ways I could actually figure this out. So I'm going to have x and f of x, all right? And I'm going to plug in some values, and I want to be able to analyze what's going on off of the chart. Which actually, without technology, this would be a real pain. We're going to start without and then end up going into using it. So let's see, if I wanted to make this table, what's an easy way, or what's a way I could find out what the output is when I have this as an input? You guys know a couple ways. Yep, you could do direct substitution, right? Plugging in -4 for all of these x's. Or you could do synthetic substitution. I'm just going to real quick do some scratch work, synthetic substitution on the side here. So -4, 1 to -3, and 1, -4, -2, +8, and I'd get -4 times 1. And I'd get 5 here. This -4 here. Yeah, I'm just deciding to start with that, see where it goes. So I get 5, so that means that 5 is the output when -4 is the input. And then let's try -3. So you could do this. This would take a long time, and we'd have 1 to -3. But you guys are getting pretty quick with synthetic substitution, right? So -3, that'd be -1, that'd be +3, and hey, what? 0? What? 0? Crazy sauce. And I could go through and make the whole table that way. Now, I'm actually going to give you access to a Google Doc that we'll end up making that will make these tables for us. And I actually already have it operating in Excel, and I'll just make the Google Doc available later. So here, let me open up this spreadsheet. All right, and check this out. Here I've got a table. All right, actually, let me change this increment to 1. Watch what happens when I change the x increment to 1. Bam. Now it's all of the inputs are counting by 1. The x start for us, we started at -4, so I'm going to start at -4, and notice all that. Now, the question is, I've got to plug in this function, and notice I have f of x equals, and I've got a term for the quintic, the quartic, the cubic, the quadratic, the linear, and the constant. And so basically you would plug in the coefficients of all of these and it would change the function accordingly. So what was our function? X squared plus 2x minus 3. So I would do 1x squared plus 2x minus 3. And notice there's the 5 and the 0 that I just had. It auto-calculates all of this for me. In fact, actually, I just had an idea. You know what I'm going to do? Yeah, it makes the table for quite a ways here. I'm gonna center align this, I think, just to make this a little bit nicer. Bam. How? See, isn't that classy? That dare to be classy. So you're actually gonna have access to this. You don't need Excel, but having internet would be helpful. I can help you out, figure out a solution if you don't. I mean, you could always make the table by hand, but I guess I'd rather you didn't. Actually, let me just put this further down here. Yeah, it'd be good. Or you can do it by hand, like I was just showing you here. So here we go. Here's a table for our function. Now, let's think about if I want to find x-intercepts of my parabola. All right, if I want to find the zeros of my graph, how could I do that? How do I approximate zeros? Well, in this case, I'm lucky. Where does an x-intercept occur on this, according to the chart? 1 occurs at -3, right? And how do I know that's an x-intercept? Because the output was 0, and 1 occurs at 1. Now in this case it's easy because they happen to land right on those values. Is this an x-intercept? Why not? Why? Why not? Because why? That's a y-intercept right there, right? Because the x-coordinate is 0 and the y-coordinate is non-zero. That's actually the y-intercept right there, if I wanted to see that. And actually, you guys, knowing your parabola stuff, you guys would have known that. And actually, it turns out for polynomials, your constant will always be the y-intercept of your polynomial. So that trick actually still works. It's a good little trick to have, friends. Now, what I also want to point out is notice the sign change for this. Notice that this value is 5, that's positive. Then it went to 0, which I'll just not mark. And then it went negative, and then negative, negative, 0, positive, positive, positive. Well, not necessarily. The rest of these are actually going to be infinitely positive, and the rest of these are infinitely positive. I know that because of the end behavior. But what I want to point out is that anytime it has an x-intercept, it's actually going to cross the x-axis. All right. I guess unless it's a ricochet, that could be an exception to that rule. But I just want to point out, notice that right every time it has an x-intercept, it crosses the x-axis, and that means the sign is going to change from either positive to negative or negative to positive. Okay? So if I was looking at this, I would have said, oh, an x-intercept has to occur. So zeros occur. Let's see, how do I want to word this? To approximate a 0, look for sign changes in the y coordinates. Okay? So, assuming I didn't know where the zeros occurred, right? I mean, because you guys could just look at this and be like, oh, the zeros occur at x equals -3 and at x equals 1. But what I would have done if I was analyzing the signs here, I would have been able to say, well, I know that the zeros occur somewhere between -4 and -2 because the y values changed there. So I would have said, the way I would describe that is with a compound inequality. I could have said -4 is less than x is less than -2 for one of them. And for the other one, I would have said, well, I know that it exists somewhere between 0 and 2. So I would have said 0 is less than x is less than 2. And notice this one is describing that x-intercept, and this one is describing that x-intercept. All right? But we want to be able to actually approximate the zeros when they don't just jump out and mug us like that, when they're super obvious. And this is how we would do it. We'd look for the sign changes. So for instance, if this went from -3 to +4, I would then say, well, there must have been it crossed the x-axis somewhere between those 2 points, is what I would have been able to conclude. So that's how we could approximate zeros. What about approximating maximum or minimum values? Here's the same table. So what if I want to approximate minimum values? Well, think about the graph. All right, if I have a minimum value, does it look like a valley or a hill? Looks like a valley, right? So something else, I mean, all sorts of crazy stuff could happen from there and here, but at the location of an actual local minimum, right, it looks like a valley. And what I want to point out is that this minimum on a chart, the only way I could determine a minimum, I have to be able to compare it to 2 points next to it. Right? I have to actually be able to compare it to 2 other points. I have to verify that its y-coordinate is less than 1 to the left of it, and it has to be less than 1 to the right of it. All right? Or I could view it this way. The graph was decreasing, and then it started increasing. So when I'm trying to approximate a minimum value, I'm not looking for a change in sign, I'm looking for a change in direction. All right. Specifically, I'm looking for it to go from decreasing. Well, I guess decreasing to increasing, yeah. But in order to conclude that, I actually still need 3 points, right? Otherwise, I would just assume like anytime it's going downhill, oh, I've hit a minimum. And it's like, no, if it's still going downhill, you're not at the bottom of the valley yet. All right, so looking at this graph, to determine whether it's decreasing, I have to actually look at 2 points. So from going to 5 to 0, is that decreasing? Yes. To go from 0 to -3, actually, how should I word that? How did I do it last year? I don't recall. Yeah, I think I'll use signs again, but these ones are just kind of going to be in between the lines. They're landing right on the lines. So from 5 to 0, it was decreasing. From 0 to -3, is that an increase or a decrease? Decrease. From -3 to -4, is that an increase or a decrease? Decrease. From -4 to -3, is that an increase or a decrease? Increase. Aha, right between there, it's appeared to have changed direction. From -3 to 0, increase or decrease? Increase. 0 to 5, increase, 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 and so on. And I actually know that it's going to do that infinitely because I'm only expecting this graph to have one bend, right? So the way I would describe this is I actually can't guarantee necessarily, well, actually analyzing further things about this graph, I would say that the minimum does occur at -1, -4. But typically, I could only make a general statement saying like, well, between here and here, right, I had to look at these 3 points. I knew that it changed direction, but it actually always will take 3 points in order to make that analysis. So I would say that a minimum occurs at the following location. From -2 is less than x is less than 0. All right, so I describe its location based on its x coordinate, but I determine its location based on the y coordinates change in direction. Right? And although this problem won't have a maximum, what do you think I would do to locate one? Yeah, look for a change in direction. Oh, that's a lot of looks. Oh, look for a change in direction. Man, I can't write. A change in direction. Where in this case, if I have my graph, maximums occur at peaks. So in this case, it's going to be, I'm going to have to compare 3 points, right, in order to actually verify this. Because to determine the direction, I have to look at 2 points. So I have to actually look at, those 2 points to see if it's increasing or decreasing, and then those 2 points to see if it changed what its behavior was. So it has to go from increasing to decreasing, right? And if that occurs, I know I must have walked over a hill. So this one is increasing to decreasing, right? And that's not going to occur for this chart. Now, once I have all that information, I could actually then roughly plot where this graph occurs. So let's do that. So based on the information I have, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I think this will be enough for us. I would first plot where my roots are, and I would have said, well, I know my roots occur somewhere between -4 and -2. So somewhere between -4 and -2, there's a root. In this case, we actually know that it occurred right here. And then I have the other one occurring between 0 and 2. And so between 0 and 2, right? In this case, I know it occurred right there. I know my minimum value occurred between -2 and 0. So between -2 and 0, I had a minimum. And roughly, what was the value of my minimum? It looks like a smiley face. Well, I can actually figure out, well, what was the y coordinate at that point where it changed direction? -4. So I'll just plot it at -1, -4. And in this case, I actually do have other points to go off of. I mean, I could technically plot any of these points. 1, 0, 3, 12, 4, 21. I could plot any of those points, but if I'm just kind of basing it off of where the x-intercepts are and where these, so like at the x-intercepts, I know it changed signs, so it went from negative to positive or positive to negative, and I know that that occurred there. I can get a rough graph of it from this point. And I know that this is a parabola. I'm not expecting any more bends, so I could expect something like that to occur. All right, so that's the general idea that I want you to know. Now, let's do another problem that's not going to have friendly points. I'll go through this next one a little quicker. But this is the idea. We're looking for the roots and the x-intercepts. Why isn't this scrolling? There it goes. So graph by approximating. So let's see if I can find a good problem for us. What if I've got f of x equals -2x cubed minus 5x squared plus 3x plus 2. All right. So analyzing this, how many x-intercepts could it have? It could have as many as 3. It could also have 2. It could also have 1. Could it have 0? Why? Because it's an odd degree, and I know that it's going to change, come in from one direction and go out another direction regarding its end behavior, so it has to cross the x-axis in between. All right, how many bends could it have? 2, yep. 0 or 2, technically. Let's see, what else did we find last time? Oh, the end behavior. Let's see, it's got a negative leading coefficient, and it's an odd degree. So that means it's going to look like one of these. Right? So how do I describe that? F of x approaches positive infinity. It's going up. As x approaches going to the left, so negative infinity. And f of x approaches, it's going down to the right, so negative infinity, as x approaches positive infinity. Right? X is going positive to the right, y is going down, is what that statement describes. So there's the end behavior, all sorts of good stuff I can gather. By the way, these bends that my graph has are called extrema, or local extrema. They're not necessarily the highest point or the lowest point in a graph, but they are the highest locally speaking. Another way we might describe them are as relative maximum or relative minimum. All right, so I might use some of that language later. So let's actually flip on over to the Excel spreadsheet, and let's set this up. So it's cubic, so 0x to the 5th, 0x to the 4th, negative 2x cubed, minus 5x squared, plus 3, I guess I just positive 3 there, and positive 2 there, right? And I'll start, let's see, actually let's start at maybe like negative 5 this time. And instead of counting by ones, I'm going to count by maybe like 0.2. How far do I get? Maybe we'll do 0.5s for fun. Let's see if I can get a good snapshot of this chart. Yeah, that's a thing of beauty right there. Thing of beauty. Beauty. So I'll go from 5 to negative 5. So instead of having you guys write this whole chart down, just follow along for now, but be aware of the concepts that we're looking for. So to determine x-intercepts, what do I look for? Well, I don't see any zeros for the y-coordinate. Here's a y-intercept. So what else am I looking for to find an x-intercept? Well, something close to 0. Is this an x-intercept, or I don't know what's close? Actually, it's even possible sometimes it might not be close by the time we analyzed, you know. Well, x-intercepts occur. What do our notes say over here? X-intercepts occur when the signs change. So let's analyze the sign change. So this number here, positive, 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 negative. Bam, we found one. So somewhere between here and here, an x-intercept occurred, guaranteed. So I would say negative 3 is less than x is less than negative 2.5, right? And perhaps you don't even need to make these symbols. It might be more obvious to you. So now it's negative, 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 positive. Aha! We found another one. We're expecting as many as 3, mind you. So another x-intercept occurs at between negative 0.5 is less than x is less than 0, right? And then it's positive, whoa, that was a fast turnaround right there. So between 0.5 and 1. And that's 3, there shouldn't be any more than that. In fact, it would be impossible for there to be more than that. Okay? And in fact, what I can do with my table, let's say I actually wanted to zoom in a little bit more. Like, let's say I was curious about this negative 0.5 to 0 situation. I actually can zoom in, so to speak. I'm like, okay, let's look at from negative 1 to 0, and we'll count by 0.1s. So if I really wanted to zoom in and get a better approximation for where that occurred, right, previously I knew it occurred between negative 1 and 0, but if I just change my increment, it's like I'm zooming in on that scale. So you could actually, so looking at this, could you narrow down where the x-intercept occurs? Right? So instead of just having this as my range, if I zoom in a little bit more, I narrowed it down quite a bit more, right? Between negative 0.5 and negative 0.4. So now, like, that's way, way better accuracy. So I just want to point out you could do that if you wanted to have closer approximations rather than just in the tenths place, right? Or halves, I guess, is kind of technically what I'm breaking it up by. All right, so those are my 3 x-intercepts. Let's find maximum. Relative maxima. Which, by the way, maxima is just plural for maximum. Relative is saying, like, within the proximity of that point, it's bigger than all of the other ones around it. Okay? Let's see. What am I doing? Crazy Mr. Waddy. Here we are. Let's change this back to the, what was it, negative 5 and counting by 0.5. Bam. I'll get another snapshot of this real quick. And actually, we'll just be able to use this table to analyze the remaining information for both maximum and minimum. I guess I'll list both. Minima. Plural for minima. Minimum, right? So let's see. What am I looking for when I'm trying to find these extreme values? What occurs around them? A change in direction. Okay? Actually, I just remembered how I used to write this. So this is a decrease, 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 decrease. 2 to negative 5.5, decrease. Negative 5.5 to negative 8, decrease. Negative 8 to negative 7 is an increase. So technically 1 occurs there. Now, do you think that's a maximum or a minimum?
Minimum.
How do you know?
I don't.
It's going from decreasing to
Yeah, it went from decreasing to increasing, so that's a minimum category, right? So I would say that a minima occurs between negative 2.5 is less than x is less than negative 1.5. How many bends could this have? 2, as many as 2, right? The fact that it has 1, I'm anticipating that there kind of has to be another one, actually. And I'd actually anticipate that it'll have to be a maximum. So let's keep looking. All right, so now it is negative 7 to negative 4 is an increase. Negative 4 to negative 0.5 is an increase. Negative 0.5 to 2 is an increase. 2 to 2 kind of like stayed the same. And then 2 to negative 2 is a decrease. So that actually means it occurred somewhere in between here. I could probably, in this case, because that was a tie, assume that it occurs between those two, oddly enough. And that's going to be a, what, maximum or minimum? And how do you know? Yeah, it was increasing and then decreasing, right? And actually, at some point, it kind of stayed the same. I know it didn't just stay 2 for that whole range. But from 0 is less than x is less than 0.5, I know that there was a relative or maximum value. And I'm only expecting as many as 2, so I think that's all I need to find. So let's graph this. Let's see, I think I've got some garbage left over from that. I can close that, don't save, close that, don't save, file, new sketch, here we go. I just want a grid. I'm just going to graph that and then delete it, bam. And let's see, I went from -5 to -5. Window, graph, grid form, rectangular, and let's see, how high do I have to go? I'm not going to go that high. Maybe I'll go to like 30-ish. No, maybe, I don't know. I'll go to 25. That's good. And I only went between -5 and 5, so I'm just going to stretch this out. So it's definitely going to be a distorted graph, just so you're aware. But that's fine with me. Because the coordinates will still be accurate. So I don't need all of the points, but I do want to at least figure out where my interesting points crossed and such. So let's see, my zeros, my x-intercepts, I had one occur between -3 and -2.5. So here's -3, here's -2.5. I had an x-intercept occur somewhere in there. Right? Makes sense? So I plot it. I had one occur between -0.5 and 0. So here's 1, here's -0.5, here's 0. So I know it was somewhere between here and here. Technically, when we did the zoom in, right, I actually knew it was between -0.5 and -0.4. So I know it's actually even closer to the left than it is to the right. Right? And the other one occurs between +0.5 and +1. So somewhere like that, maybe. Here's +0.5, +1. So I'm just throwing my points in there. Based on my, let's see, that's another thing I've got going, is my end behavior. I know it looks like this there and this there. So I know this is kind of coming from this direction and going out this direction. But I'll leave that until after I plot some other stuff. But I just want to point out we do know that. Let's see, for minimum value, or maximum, we'll do the maximum first. It occurs between 0 and 0.5. 0 and 0.5. What should the height of that value be, do you think? Well, yeah, it's probably bigger than 2 because it was increasing as it got there. And I'll put it somewhere here, I don't know, maybe 3-ish, 4-ish, I don't know. What I could do is actually plug in a point closer than that, like maybe plug in 0.25 and see what happens. But yeah, we'll make it just a little higher than 2-ish. And it was what, between 0 and 0.5. So there's our summit right there.
And it's the y-intercept is 0, 2.
Oh, 0, 2 is the y-intercept. Another good piece of information. And then I have a minimum value occurring between -2.5 and -1.5. So here's -2.5 is right there. -1.5 is right there. So it's somewhere in this range, right? How low does it go? Somewhere around -8. Could be less than that. So I'll put it somewhere around -2 and I don't know, somewhere like that. So now I'm just going to go through and kind of connect these dots. So I'll kind of have it do one of these, one of these, and one of these. That's my maximum. Crosses, and then I technically do have other points I could base it off of, but I'm just going to make it do that and that. Right, something to that effect. I technically could have been like, oh, at -3, it's going to be at, sorry, that's +3, it's going to be at -88, and go there and plot all the way. I could find those other points, but I kind of am solely interested in our transition points. Y-intercept's not a bad one to throw in there as well, since that's easy to get. So there's our graph. Let's actually see what the computer generates for a graph and see if we were right. And then I think we'll be done. So let's graph this. This is -2x cubed minus 5x squared plus 3x plus 2. That's pretty good, guys. Yeah, we did pretty good. There it is on exactly the same grid I just had.
It's the same color.
Yeah, I did pretty good. Yeah, look at that. That's pretty accurate, I'd say. Right? Right? I guess I could put this as like a little side-by-side, actual versus approximated. It's not bad, right? So I just want to point out that this does work out. So it's kind of a good way to find approximations. But the logic, I think, is what makes the most sense. The idea that you can find these x-intercepts where the sign changes, right? Right? Because this went from positive to negative where that x-intercept occurred. All right, so that's all there is about that, folks. Thanks for watching. Have a great day, internet friends. Bye-bye.